FastMCP3's namespacing mechanism resolves component naming conflicts through systematic prefixing, enabling modular server composition without manual renaming. This hierarchical naming strategy applies underscore-separated prefixes to tools and prompts while using path segment prefixes for resources and templates, maintaining clean separation between mounted servers. We're about to examine how two independent FastMCP servers, each defining a getData tool, can be safely combined under a parent server using namespace parameters during mounting. The code will demonstrate how this transformation automatically generates distinct component names like weatherGetData and calendarGetData while preserving the original functionality. From FastMCP, import FastMCP. Weather FastMCP weather. Calendar equals FastMCP calendar. At weather tool. Def getData SDR. Return weather data. At calendar tool. Def getData SDR. Return calendar data. Hash without namespacing. These would conflict. Main equals FastMCP main. Main mount weather namespace equals weather. Main mount calendar namespace equals calendar. Hash client C. Weather getData calendar getData. This example demonstrates how FastMCP3 uses namespacing to resolve naming conflicts when composing multiple servers. The pattern shows two independent servers, weather and calendar, both defining a tool with the same name getData. Without namespacing, mounting these servers would create a collision since both expose identical tool names. The solution uses the mount method with a namespace parameter to prefix all component names from the mounted server. When weather is mounted with namespace equals weather, its getData tool becomes weatherGetData in the parent server. Similarly, calendar's tool becomes calendarGetData. This underscore-separated prefixing applies to tools and prompts, while resources and templates would use path segment prefixes in their URIs. Namespacing enables modular architecture, where teams can develop servers independently without coordinating tool names. The trade-off is slightly longer component names for clients, but this is preferable to either manual renaming or potential runtime conflicts. The pattern scales well for large applications where domain separation is critical, and the namespace transform can also be applied directly to a server if all its components need consistent prefixing. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core server functionality for the Model Context Protocol MCP framework. This class is the foundation for creating FastMCP server instances. Weather FastMCP weather creates a FastMCP server instance with the identifier weather that will be used in MCP protocol handshakes for client identification. The string parameter serves solely as a server label and doesn't configure any operational behavior. Calendar equals FastMCP calendar. Creates a FastMCP server instance with the identifier calendar. The string parameter serves as a server label that will appear in MCP protocol handshakes to help clients identify this server, but does not configure any functional behavior or operational mode. At weather tool, def getData SDR. Return weather data. Defines a function getData decorated with @weather tool, which registers it as a tool in the MCP protocol under the weather namespace. The function takes no parameters and returns the string weather data. The decorator exposes this function as a callable tool through the MCP interface, using the function name getData as the tool name since no explicit name parameter is provided. At calendar tool, decorates the function below with the @calendar tool decorator, marking it as a tool within the calendar namespace that will be exposed via MCP. The decorator doesn't take any parameters here, so the tool will use the function's name as its MCP identifier.
Def_getData SDR
defines a function named getData that returns a string value. The function signature indicates it takes no parameters and will return a string type, as specified by the SDR type hint.
Return calendar data
returns the string literal calendar data as output.
Main equals FastMCP main.
Creates a FastMCP server instance labeled main for identification in MCP protocol handshakes. The string parameter serves solely as a server identifier and doesn't configure functional behavior. This establishes the root server that can later have other servers mounted into it for composition.
Main mount weather namespace equals weather.
Mounts the weather server into the main server with a weather namespace prefix. This makes all components from the weather server available through the main server, with their names prefixed to prevent conflicts. Tools and prompts from the weather server will be accessible with weather prefix, while resources and templates will have weather in their URIs.
Main mount calendar namespace equals calendar.
Mounts the calendar server into the main server with a calendar namespace prefix. This makes all components from the calendar server available through the main server, with their names prefixed to prevent naming conflicts. Tools and prompts from the calendar server will be accessible with an underscore separated calendar prefix, while resources and templates will have the prefix as a path segment in their URIs. FastMCP3's namespacing mechanism elegantly solves component naming conflicts through systematic prefixing, enabling clean modular composition. By mounting independent servers like weather and calendar under a parent server with distinct namespaces, their identically named getData tools automatically resolve to weather getData and calendar getData. This underscore separated prefixing for tools and prompts, combined with path segment prefixing for resources and templates, maintains strict separation between mounted servers. The trade-off of slightly longer component names is minimal compared to the benefits. Teams can develop servers independently without coordinating names, and large applications can scale with clear domain separation. The pattern demonstrates how FastMCP's hierarchical naming strategy preserves functionality while enabling robust server composition.
Two getData functions collide in silence. One summons storms, the other birthdays, yet neither stumbles.